Thanks, Mike. Distinguished guests. Appreciate you allowing me to provide a tour for you today. My name is Adam Felber. I'm an engineering manager at the Fridley site. We'd like to begin this plant tour with an aerial look at the site. This is the Fridley plant where we produce gensets in the range of sub 10 kilowatts all the way to 3.5 megawatts, rental, military, consumer, home standby, and of course our high horsepower data center, hospital standby applications as well. Just a quick orientation to the site. It's 122 acres. The site has been used by Cummins and Onan since 1969. Right now you're looking at manufacturing space kind of in the background here. And notice that we're in kind of a residential area. I'll get to that when it comes to sound attenuation in just a moment. But this is primarily the manufacturing space. It's about 500,000 square feet. We build product based on the parts that we're receiving from our warehouse. So we have a 350,000 square foot warehouse attached just adjacent to the plant, connected by a corridor here. So the parts will be, they'll be brought up to the plant and the product will be built, tested, and then we have a couple of shipping options. The west side of the plant here, there's some docks for our consumer, home standby, marine type models. And then on the east side, we've got a dock that handles our larger and our military products. So you can kind of see that in the background. A couple of things we're going to see today on our tour will be the interruptible room, which is going to be our first stop inside. That's located right here on the site. We've got some backup power for the plant. Within the plant itself, we have a smaller production genset line, which is located roughly where my cursor is in the middle, and it runs to the east. Our second stop is going to be for our high horsepower genset production. That begins approximately where the cursor is here and runs to the east as well. And then we're going to see the test area for our high horsepower product, which is this white two-story area here. This was built in 2011. One thing to note, on our warehouse, we've got about 500 kilowatt of solar array that's attached. And the reason that is here is so that we can offset the plant's energy consumption. And we've got a microgrid lab. This photo is a little bit dated now, but it's going in kind of in this left corner here. That lab is going to allow us to connect solar with our generator sets, both diesel and natural gas, or even propane, also with battery inverter technology as well. So we're really excited to get that system up and running. It's in construction. Another thing that's sometimes asked for that I won't go into today too much is our acoustic test cell. That's located here on the east side of the campus. So I'm going to go ahead and switch over to our other view here. Bear with me one moment. So this is within that first stop that I talked about. This is our interruptible conference room, and we use this room to demonstrate our product's capability to our customers. And we do that by having our gensets, which I'll go to here in a moment. We've got a mechanical room with 4 50-liter product. They're 1,100 kilowatt prime or 1250 standby diesel generator sets. And then adjacent to it, we've got our switchgear on this side. And to control the whole system, there's actually a couple of cabinets right on the other side of this wall. And unfortunately, I can't zoom right in on the screen, but it's a touch screen interface that allows all of the orchestration of the utility feed plus a generator to show its current status real time. So it's a very neat setup. Let's go ahead and walk through this room a little bit. So you can see we use this room. We also demonstrate some of the older controls that we had. And we have this cool feature we can walk right through walls with this little tool. So this is one of the 4 of our 50-liter diesel genset product, again, 1250 kilowatt. They are connected with the Cummins Stanford P80 Alternator. I believe these are a medium voltage arrangement. And we've got, I believe these are a Modine radiator package here. On the other end, you can see we've got acoustic suppression for the exhaust system, and we've got intake, cooling air, and combustion air acoustic suppression. Again, we're in a residential area. We need to be really mindful of that aspect. I'll just kind of step over here. You can see the other machines. You can see we've got them sitting here, vibration isolators, and we can back up the plant at any time through a closed transition. as was just spoken about. I think it was by Jeff and Chad moments ago. And we have enough power capability that we can export to the grid. And from time to time, we are asked to do that to offset the grid demand. I think the last time that I'm aware of that was done was during the natural gas shortage. There's a pipeline that was coming from Canada into the Minnesota area, and that gas pipeline became compromised, and they asked us to go online, and we were running on our own generators for I don't remember the exact duration, but it wasn't just a couple hours. It was over a week, if I remember correctly. Here you can see our switchgear setup. The switchgear arrangement was put in just a few years ago, so it is our most modern switchgear arrangement. So the next area of the plant, if you recall, this was kind of the centrally located area where I talked about a smaller commercial production area. So that's just to our right in this image. What I do want to do is just take a moment to show you in the foreground here, you can see some of our historical product. This plant just celebrated or just passed the celebration point of 50 years of genset production. Before that, it was located closer to University Avenue in Minneapolis. And so these products are different product that were built at this factory over the years. This green one, you can see it's an OD green, kind of telltale. That's a military product. It's an Onan J series. It's an air-cooled diesel. We also had spark versions of that engine. The white units here, these are marine units for yachts, pleasure craft. And then these green models are for either commercial or RV applications. The next area that I'd like to spend some time on is our high horsepower line. So this is our second newest production line. This line is located on the kind of southeast corner of the plant, as I pointed out, and they produce power up to 3.5 megawatts. And we do that by using Cummins diesel engines in the range of 30 liter. We've got a couple of 50 liter variants, 50, a couple of 60 liter variants, 60, and those go up to 2.5 megawatt. We've got some 78 liters that we build on this line, so that'll do 2.75 megawatt. And then the big one, the 95 liter, that's Cummins' largest diesel engine, production engine. Let's go ahead and walk down this line. A lot of similarities to what we saw when we looked at line 1, in that we start with a chassis, and that chassis, instead of having a conveyor system that we saw on the other system with rollers, we use a drag chain setup. So I wonder if you can quite see it. That you can kind of see there's a small trench here. So there's a chain that's in the floor, and this front, we call it skate, has a tongue, not unlike the tongue on a trailer for a vehicle, which connects to that chain, and it drags all the units forward in unison. To achieve that, we have certain safety features on the line, which I'll get to just momentarily, that they use light and laser beams to ensure no one is within inside this kind of yellow envelope here. Again, Cummins is very serious on safety, and that's just one of our ways that we help achieve that. So let's look at a little bit of the product and talk about the line as we go. So this particular machine is a 60 liter design. It is going to have a radiator mounted to it. So you can see on the chassis, we've got this extension and widening of the chassis. This is where our cooling package will be mounted. This is the largest machine that leaves the factory with a mounted cooling system. And these are capable up to, we have 40C cooling and 50C cooling options, as well as remote radiator options if you choose that. If we go just step a little bit further, this particular one has a P7 alternator. It's another Cummins product, is the Stanford Alternator. This is capable up to 2.25 megawatts. You can see the basic design here. 4 turbochargers, V16 design. If we turn around a little bit, I think you can see there's an alternator prep station. I don't exactly see, you can see a smaller machine here. So the alternators are just like we saw in line 1. we tailor them before we mount it. And the idea with that is, and with any subassembly, is we're trying to keep very consistent the amount of time that we spend on the flow part of the line, kind of off to the left. Trying to keep that very consistent so that we don't have operators standing around waiting on the station ahead of them or behind them, kind of maximizing our manufacturing efficiency. And to do that, we have subassemblies. In this area, they're mounting current transformers, leads, and anti-condensation heaters right here. Let's go ahead and step a little bit ahead. So this particular machine, this is our 95. This is the biggest one that Cummins makes. It's a nominal horsepower of about 5,000. This engine is used in the power gen application, as you're looking at on the screen now, but it's also used in mining applications, in marine applications, locomotive applications. And if you're thinking to yourself, wait, locomotive, yes, we have locomotives running around North America that are powered by one QSK 95 engine. And those are actually tier 4. So they've got extra after treatment systems that are jointly acquired to make that system work. So it's a really cool design. It's a high-speed diesel, runs at 1800 RPM. The design is capable of a 500-hour service interval. And we're able to get that by having significant oil consumption, or excuse me, oil pan capacity, in addition to the fuel filtration and oil filtration that can handle that kind of duration. So in this system, you can see we've actually got 2 banks of fuel filters here, and there's a third bank if the customer desires, which is mounted a little bit lower down here. You can see our high pressure fuel pump. We've got engine breather options. This is just one. We offer several designs for this. Another V16 design using 4 turbochargers. And this particular one has the Cummins P80 Alternator. This is not our largest alternator, believe it or not. We have a DIG, which is roughly twice the mass and inertial mass of this machine. But this is a low voltage P80. It's got a nice rollback feature here. So there's actually wheels which will bolt to this design because at some point in the product's life, bearings and there's a flexible drive coupling that's bolted to the flywheel. Those need to be serviced. It's a good while away from when it's new, but it does allow servicing of the machine without needing to have a mechanical room that has a crane in it. So that really helps reduce the cost, the installed cost for our customers. So this 30 liter is capable up to 1 megawatt. It's also got installed radiators that we mount to that. It's coming out of Seymour, Indiana. So every one of these, just like the 95s and that 78 gas, those are coming out of our Seymour, Indiana engine plant, shipping up to Fridley. And let's see if we can see any other. Yeah, the terminal housing is starting to be mounted on this design. The terminal housing, we offer different options, left side and right side entrance. Customers sometimes choose a top entrance depending on their mechanical room or enclosure architecture. We offer circuit breakers in this range of product as well, and I think even up to our 60 liter products as well. So it's not quite complete yet, but you can start to see some of the things take shape. The harnessing has been installed, the leads for some of our control. So the control is actually a rear mount. I can see the brackets here and here. So that control is going to be placed pretty soon. I'm going to jump a little faster here. Another 60 liter. This is our DQKAN, so it goes up to 2.5. We've got our paralleling control placed on it. Once the units come off the line, they'll actually program them here at this station. Again, each unit could be unique. We want to make sure it matches the customer's application. And then it's time to test it. So I'm going to kind of quickly move over to our test area, trying to be respectful for everyone's time. You can see some completed units here. So every unit gets tested, and this is the path. We're walking the path, if you will, right now to the test area, which is it's off to our right. There's some smaller, older cells here. We'll do up to 78 liter testing there. And then I'm going to go back into this room in just a minute, but I want to point out, because we won't be coming back, that once they're done, these units look pretty much like what you see here. 60 liter design, mounted radiator. If we happen to have any scuffs in the paint, during movement. It's possible. These are heavy machines, and we're moving them with some pretty powerful equipment. We've got a touch-up booth here, which will meet our quality standards for paint application. So that's what you can see here. All makeup air. It's got ladder lifts in here. It's a really nice setup. And then off to the left of this, that's that commercial east shipping dock that I was talking about. So I won't be able to spend any time going over there. Well, here's a 78-liter diesel engine. Again, 2.75. That's how we receive them on these non-returnable wooden racking. We do that because those actually come from our Daventry, England plant, and returnable racking just doesn't make a lot of sense to ship back across the ocean. That one's a V18. It's a 4-turbo design. So the 78s and the 95s, or any 60-liter with a witness test, that'll come back into this space. So this was newly built in 2011. This space is high horsepower test. There's 4 cells. The left 2 that we just passed actually they test a military product, so I'm not going to spend any time on that. But what I will show you, the 2 cells on the left are the same, and these are actually the original development cells for the 95-liter genset. The engine was developed in our Seymour, Indiana plant primarily, and then the genset design happened here in the Fridley site. So what you're looking at, again, a clone of the one next to it, is a cell that's capable of running up to 4 megawatts electrical power, low, medium, or high voltage. Right now, there's a 95-liter genset installed in the space. You can see our different load bank cables here to accommodate our different voltage range. We've got flexible exhaust, which has got a joystick control for alignment here coming from the roof. We can do mounted radiator or units with no radiator, and we achieve that by, you can't see it, but there are very large 6-inch diameter flexible rubber hoses, which we couple up to the water pumps on the engine, and that circulates water through some heat exchangers that sit outside. We've got full spill containment trenching around here. It's difficult to see, but there's an infrared detection camera here. So if we ever, in the unlikely event, ever have a fire or an arc event of some kind, it will immediately shut fuel off to the cell. So it's a safety feature is there as well. These cells are capable of running up to 50 C ambient. Again, it was for development, we needed to be able to replicate our customers' application. So you can see there's about 600 horsepower of fans that move air through this plenum space. It's kind of hard to see just because of the video, the way it was taken, but there's about 2 stories of plenum space up there. Oh, that's interesting. I can actually walk in the cell. Yeah, you can see the opening here for the radiator attached units, or this is the valving and the piping for the non-radiator units. You can see our battery banks here. But because we can run the air temperature up on these cells to 50 C or depress it down to 0 C using chillers, we've got air conditioners that go right on our switchgear assemblies to make sure that they're healthy through all of our loading conditions. And the last thing I'll just spend 1 more minute on is these cells, they need to be run. No one's allowed to go in those cells when they're running. These things, again, it's a locomotive engine, so they're quite loud, a lot of pressurized fluid, flammable fluid, and so forth. And we want to make sure that when we prove them out, they're safe for our customers. They operate as they're intended to. And that's how we do it. We don't let anybody in the cell, and instead we invite customers to come to the plant or do a virtual witness test. In a witness test, we walk through the entire production test sequence, and we offer special tests, kind of in an a la carte fashion to meet your needs. So your specifying engineer can come right into this room, interface with the technicians. You can see we've got environmental controls here. We've got different cameras that allow us to zoom in very high resolution on, you can see a drip from a hose if there were a leak. I mean, it's a very good quality video. We've got load bank control, which would be on this screen here and here. We can tap right into the ECM, the engine computer, or onto the generator computer. That's done through this one. And we've got high-speed data acquisition that allows us to take frequency and voltage traces at 10,000 hertz sample rate based on the customer's needs. So that's pretty much it. These cells, again, they have the same kind of aspect going. I think we're about at time, and I'm going to turn it back over to you.